Tracy, you know what a lever is, don't you?
Yes, like a seesaw.
Well, that's one kind of lever, and here's the sort of seesaw right here. Well, there are actually 3 different kinds of simple levers, and I've collected some common tools from around the house to illustrate the 3 different kinds. Let's start with this kind.
Okay.
The fulcrum, or the pivot point, is in the center, in the center section anyway. Then you want to accomplish some work, so I'll put this book as a weight over here. Okay. Then you have to apply effort over here.
To lift the book up.
Right, to tilt the book up. So those are the 3 important parts of the lever. The fulcrum, the work, and the effort. Okay? What would happen, by the way, if I move the fulcrum closer to the work?
Well, I'd have to do a lot more distance to get the same amount of work done. Yeah. Then in the middle, it was an equal distance. But
you didn't have to exert as much effort over there.
Right, it was really light.
Through a greater distance. What if I put it up here?
It's heavier, but I don't have to move as much.
Same weight.
Well, it feels heavier.
Feels heavier because you're not being able to exert as much force because of this short distance and that long distance. Okay, so when engineers design tools based on the lever principle, they use those principles, keep those principles in mind. For example,
the scissors.
The scissors. Okay, where's the fulcrum, the pivot?
Right here in the middle.
Where are you going to, the effort?
Right here, the
and
handles.
where do you accomplish the work?
Here at the shoulder.
And why is the pivot point so close to your fingers?
Well, so I just have to exert a little bit, and I get a lot out here. Right. If you put it closer, then you could just do a little bit.
Right.
A lot more.
In other words, you want to get a greater distance. You want to move through a greater distance when you cut. Compare that to this lever, which is based on the same principle.
I mean, you have to do a lot to make this, to do a little up there.
Yes, but you can pinch with greater force.
Right.
Right. Which is why they design a pair of pliers using that principle. Now let's go to the next one.
Okay.
I'll put the fulcrum at the end, like that. I'll put the book here. That's the work. And you apply the effort there.
Well, I move a little bit, and that moves a lot, and it's
Wait a minute. You move what? You move
a
lot.
lot, and this moves a little.
And it moves a little. But you
it's heavier.
Yes, but you could exert now. The closer I move it to the fulcrum,
right,
the easier it is for you to do it because of the leverage.
A nutcracker?
Isn't that the fulcrum is up here, right?
Oh, I see. And you put the force down here, and you can apply more pressure.
Yes.
There.
And if I put my little finger right there, you could crunch it. Right. How about this one? Same idea?
Well, yeah, a garlic press, because I need to move a lot to get a little up here, but there's greater force.
Right, because you want to squeeze out the juice from the garlic. Okay, there's one more left. This time, I'll put the fulcrum at that end where you are.
Okay.
And I'll put the work way out here, and you have to exert the pressure by pulling up over here.
Okay.
I'll hold it so it doesn't move.
Now, well, I move a little bit, and that moves a lot, but it's heavy.
Yeah, it seems heavy. You have to exert a lot of force. Why would you want to do that? Notice the speed, or the distance through which it goes. You move that through a little distance, watch what happens to the book.
It moves quite a bit.
Yes.
Sugar tongs? Oh, I see. Here is the pivot point, where you apply the pressure or the work, and here's where the thing is going to be done.
Yeah. Now, can't you think of another example that's a little more common, in which there's a pivot point at the end, the fulcrum. You exert a little force here through a small distance in order to make that go much faster up here, which is what happens, right?
Right. Baseball bat?
Yeah, take a look at a baseball bat as a simple lever. Where does it pivot?
Right here, at the end.
Where do you apply the force, the effort?
Right here.
There. And where you're trying to make that go?
Fast.
Fast. So whenever you use a baseball bat, you're using that simple lever. And other levers, athletic equipment works on the same idea. Tennis racket, hockey stick, golf club, all based on a simple lever.